Hello, hey folks, welcome back to my channel. Pretty excited today. We'll be today going through WebRTC. We'll be knowing or what WebRTC is and how to set it up and how to make it work and boom. Okay, so let's get started. So let's get started about WebRTC for front-end devs who loves to keep it personal. Yeah, now the fun over there. Real time, real pain, and real fun. So let's get started. Let's see what this talk covers and probably doesn't break. We'll be going through what even is WebRTC and why does it exist. And we'll be also going through where does it gonna servers, and we'll be looking at how two browsers even talk to each other directly without any servers in the middle, direct peer-to-peer communication and signaling and communicating via data channel and data stream and security concerns around this. So let's get started. So as we know, before WebRTC, like when we have to make a communication between one browser to another browser, we would need a middleman. We would need a server like this. And from one browser we'll be communicating to the server, and that from that server we'll be communicating to another browser. This is how the typical MV's internet communication works, right? So in WebRTC stands for Web Real-Time Communication. We can make one browser to talk with another browser directly without any middleman, and you can communicate audio, video, and data, and that's a direct peer-to-peer communication. So let's see where does it gonna serve us. So when we want to achieve very low latency and real-time communication, be it like game, video calls, and such things, when we want to minimize the load on the server and we would really want some like high low latency stuff, this is gonna be helping us. So some of the cool examples that you might have seen is the Figma cursor, where you can see the other person moving their cursor as well. So for this sort of like low latency stuff, you would need WebRTC. So let's look at how do two browsers even talk with each other. So there are few key concepts which you would have to know. First would be the RTC peer connection. RTC peer connection. So this is an object, basically your browser API provides it, and RTC peer connection manages the connection between two peers, handles the negotiation, streaming, and network behind the scenes. And basically this is how you would be creating a peer connection. You would be entering the new RTC peer connection and you would be providing the iServer URLs. iServer, I come to it now. Let's just see, take it as some URL you are passing, and ICE transfer port will see all. And this is the RTC peer connection. And next we'll be going, we would have to know what SDP, Session Description Protocol. So what the textbook say is a blob of metadata describing peers capabilities, including codecs, IP candidates, and encryption info. So basically what an SDP document is, it tells you your capabilities. Suppose just let's imagine that you are communicating to a friend of yours, whether it might be an iMessage or WhatsApp. So what are the things that each of you should know? Each of you should be knowing that what are the things you're gonna be accepting. Like you can take in an image, video, or an audio message and a text message in so and so language. These are the descriptions of your communication capabilities, right? So this would be your SDP, and here the SDP would be created by both the peers in the communication, and they would be exchanging with each other. So and this is how you would be creating the offer. Okay, let's see what are offer and answer. So basically the one who initiates the communication in our WebRTC is called as the offerer, and the one who joins the communication is called as the answerer. So offerer would be able to create the peer connection. From the previous step you might have seen we had created an object called peer connection, and from that we can create the offer. And this once we create the offer TP, we should set it as our local description, and then we would have to pass this local description SDP, offer SDP to the answerer. And the answerer, same way he would be creating the answerer SDP, and he would be setting it as his local, and he would be passing that up. And stun servers, we would have to know what stun server is. I told you that we will be talking about it. Okay, here is it. So stun server stands for session traversal utilities for NAT servers. Basically, this helps us identify our own public IP address, which will be used in ICE candidates. I'll come to it. So it will help us recognizing the public IP candidates to be communicated with the other client. Why is this needed? Let me give you an example. So imagine you are in a classroom and you want to invite your another classmate to your house for a party. So what are the things that you need to know? You need to know your public address of the house. So you ask the teacher in the class. So the teacher here in this scenario is the stun server, and ask the teacher what your public address is that you can share with the other peer, other classmate, so that he can come to your house. So teacher, then the stun server would give you the public address which you can, from which you can start gathering the ICE candidates, and that can be communicated, and stun server becomes useful. And then you need to know ICE candidates, interactive connective establishments. So it's a framework that tries different network paths to find the most efficient way for peers to connect. What does this actually mean? Just imagine you are playing with your friend and you are inside the house and your friend is outside the house, and he has to come to you and he has to communicate a message to you. So you would see there are multiple ways for him to enter the house: through main door, through the back door, through the window, or through the attic. So there are many ways. So you would need to have the most efficient and the shortest way for the communication for the entering to happen. So this is the ICE candidates, which defines the most easiest, closest path, efficient path for the piece to connect. So this is the ICE candidate. So okay, now let's look at parts of WebRTC. So as I spoke, there would be one candidate who initiates the communication, would be called as the offerer. And the second candidate is the answerer, another browser, and the signaling server. So what signaling server is? As I was mentioning you regarding the things like SDP and the ICE candidate, these documents and the ICE candidates needs to be exchanged between two of the peers with each other, and for that you need some sort of mechanism. So this mechanism, this server, this exchanging part is called as the signaling part, and the one who takes care of it is called as signaling server. So on the first step, the offerer creates the session description protocol, which explains the capabilities, codecs, IPs, and those stuff. And he sets it as his local SDP, and then he passes that local SDP to the answerer via the signaling server. And once the answerer receives the SDP, he will be setting it as his remote SDP, and then he would be creating his own SDP, and he sets it as his local SDP, and then he passes the generated local SDP to the offerer, and offerer sets the received SDP from answerer as his remote SDP. Okay, here the SDP exchanging is complete. Now look at the ICE candidates. It also takes care of what's in the same manner, 3 candidate signaling server. And once the offerer creates the data channel or the data stream, the ICE candidates generation starts. And once this is started, both of them exchange the ICE candidates and they add it to their RTC connection. And once this is done, both of them are now capable of exchanging the messages and the data via the data channel or the data stream. Yay, and this is done. This is cool, right? Okay. Now let's see what part of WebRTC does not take care of. Signaling. The mechanism of exchanging the ICE SDPs and the ICE candidates are with something not governed by WebRTC. So it's left up to us how we are gonna implement it. So there are several mechanisms for exchanging the SDPs. Some of the popular ones being WebSocket, Socket.io, and Firebase real-time database, or even pigeons. You can just write down the SDP and the ICE candidates, and you can exchange the document and add it up in the RTC by manually typing it, and that thing also works. So, but it defies purpose. But yeah, that can be done as well. And let's talk about security concerns in this. So all WebRTC data are end-to-end encrypted. No option to not encrypt. So it's enforced by the browser APIs by default. And media channels use SRTP and data channels use DDLS for communication. And WebRTC primarily uses UDP and it can fall back to TCP if necessary. And now let's see it in action. Okay, let's look at the demo now. So here I'm having two browsers opened up. I built a small POC app. Let's consider this as one client and another client. And in the middle, I'm running my signaling server. So from the one server, I'm logging in as Joy, and let the room name be Summy-dot-dev. So I hope you guys know how this Socket.io works. Socket.io basically gives us the setup of rooms in which we can make the connections and we can broadcast the message and it would reach everyone else in that room. So that's how the Socket.io works. But since that's not the main agenda of this, we are not going to be covering that. So after this, here we will be logging in one of the user as Joy in the room Summy-dot-dev. So let's see, he has been connected to the socket and he's joining. He has joined the room Summy-dot-dev named Joy. So from the another second client, let's see. Yeah, in the signaling server we can see that he got joined and he's requesting to join the room, and Summy-dot-dev room does not exist, so room has been created, new room has been created, and the room status is now Summy-dotdev, this ID key, and he is in the room. Okay, now make the another client login as well. Let his name be Roy and the name is room name would be Summy-dot-dev. Whoa, too many things happen. Let's break it down one by one. So we can see another user login event at the signaling server. Name, username Roy, user ID is this, and room status is so and so. Currently only Joy is in the room, and room join request has been made by this client, and user is trying to join the room Summy-dot-dev. Room Summy-dot-dev exists and the user Roy is joining the existing room Summy-dot-dev. Nice. And once that's done, from the signaling server, I'm triggering the initiate WebRTC procedure to the offerer. So that event has been triggered, and now let's see what's happening over here. So as we could see, once he had joined and he was joining the room and he had joined. And he also received the message, signaling message from the socket server that a new user has joined the room here. So now next we have from WebRTC server, signaling server, we received the event to initiate the WebRTC procedure. And now he has just set up the data channel and event listener, and it has been created, and now he is creating the offer SDP, and the offer SDP has been created and is set as local description, and he then emits the offer. So once emitting is done, we can see the signal server here. The user Joy is sending the offer to the room Summy-dot-dev. So in the socket room, he has the message, the offer SDP has been broadcasted, and that should have reached the another client. Let's see. for joining the room. He joined the room and received the offer. Yeah, he has received from the socket. Once that was done, the remote description was set successful. So the offer which he offer STP which the another client Roy received, he has set it as his remote description, and he is creating the answer SDP. And once the answer SDP is created, he is setting it as his local description, and he emits that answer SDP through the server, and we can see user Roy is sending answer to the room Summy-dot-dev. So he has sent the answer SDP, and we can see whether we received here. Yeah, we can see that it has been received by the Joy client as well, and the remote description is set successful over there in the Joy's end as well. And now, as you can also see, the ICE candidates generation has started already, and it has been emitted by each of the clients, and both of them are adding them up. And now the connection has been established between both of them. Change to connected. Now let's see. From here, from the Joy, I will try to send a message. This should be directly via the RTC feed connection. See, the message has been sent and the message was received here immediately, instantly. Though this looks like from once in the same screen in the same browser happening, but here it's going through and having a direct communication between one web client to the another web client, and there is no middleman here. Only for the exchanging of the SDPs we wanted a middleman. Apart from that, we didn't need anything. So this is how the WebRTC works. And let me show you some of the code how I have created it. So let me open up my cursor. Okay, so now this is my setup. I have created a small React hook for managing the WebRTC. So as you can see, I am creating the peer connection over here. Peer connection reference. I'm creating a user for exchanging that, and here I'm creating the new RTC peer connection object and setting it in the ref. And for creating the offer, I'm doing it like this. RTC peer connection object, on this I'm creating the offer and setting it as local description, and then I'm returning this in this function. And in the same way, in the answer, I'm creating the answer and setting it as local description and passing it. And there is one more function I have for setting the remote peer description. Once that's received, it will be set in the peer connection ref object. And these are the total all the functionalities of this webhook that's providing. Initialize peer connection, create offer, create answer, remote description, and the same way in the server I have this thing, but server depends on like how you would like to implement. You can have anything over there. So this is just the basic socket structure which I have a room setup where once anyone can broadcast a message. Once the broadcast is done, it will be reaching other socket IO clients which have been connected. So yeah, this is pretty much it, and I hope this helps you in any of your projects, be it in your personal hobby or in your work projects. And if you want, you can really feel free to reach out to me. These are my handles, and if you want help in setting up your WebRTC connection for anything, please do reach out. And that's it for today. We'll be catching up again soon, and we'll be trying to come up with some of the another exciting things to discuss about. So tata, see you, bye bye.